Queues are the job queue, the ready queue, and the waiting queue. Device queue is fine too. Yep. So what's the purpose of the job queue? All the jobs that are on the system, all the PCBs that are on the system, all the processes that are on the system, however you wanted to say it. All right, and the ready queue is the ones that are actually in line for the CPU. So it's a subset, well, potentially a subset of the job queue, right? So anything that's in the ready queue would potentially be in the job queue, but nothing would be in the job queue. I'm sorry. Anything that is in the job queue would potentially be in the ready queue, but nothing that's in the ready queue would be omitted from the job queue. So the job queue contains every single PCB in the system. All right, what about the waiting queue or the device queue? Okay, waiting for I/O crap or something like that. Okay. All right. So, homework, we were supposed to create some sort of simple process scheduler that is the dude who's in charge of those queues, right? Is that an accurate statement? All right, so let's go ahead and let's create a class here. New class, let's call this process scheduler. All right, and the process scheduler is going to maintain some queues, right? And each of these queues are going to have PCBs in them. All right, so let's create some private linked lists of PCB. Let's call this the job queue. Private, here, let's go ahead and import java.util. So private linked list, PCB, the ready queue. Then private linked list, PCB, the waiting queue or device queue, whatever you want to call it. All right, so three different, that's kind of a cool one. Thanks. So three different queues for holding different pieces of information. Now the process scheduler is, what are some of the things that he can do? What are some of the things the process scheduler is capable of doing? Well, does he generate a new PCB? All right, so he has the ability to create a PCB. What does the process scheduler need to know when he's first born? Does he need to do anything special other than initialize these three queues? So I'm the process scheduler. So the new business is opening, the operating system, right? Brand new Walmart. All right, and they've hired some folks to initially staff the Walmart. And one of the people they've hired is the process scheduler. So, and the process scheduler manages the dudes that are some of the patrons that come into the Walmart, right? The PCBs, right? So the process scheduler has to be there first. So PCBs don't exist yet, but the process scheduler does, correct? All right. What does the process scheduler need in order to do his job? I've created three lines here, three different queues of folks. Based on our understanding of the process scheduler at the moment, does he need to know anything else? What instructions? what process? So think about this as the guy who was hired by Walmart to man electronics. Okay, so until a customer comes up with a problem or with a question, does he need to know anything to work, or is he there to serve the customers? Okay, on behalf of Walmart. This guy's here to serve the PCBs on behalf of the operating system. Make sense? So as of right now, let's go ahead and create an empty constructor that doesn't take anything in. We might change this later, but for right now, nothing. So we'll say public process scheduler, takes no parameters, and let's say does nothing. So what we'll go ahead and do is just call super, our parent's constructor. All right, but we'll go ahead and throw this in here for some back knowledge. This line is actually not required in Java. It's assumed if you don't put it there. All right, so remember all those things like in Java, this guy extends object, but we don't actually see that. Right? Similarly, this guy does make a call to his parent's constructor first to do any special, hi, I'm an object at the very least setup. All right, so we'll leave that in there now just so this guy looks like he does something. All right, so now you're the process scheduler. Somebody double clicks on the Microsoft Word icon on the desktop. What happens? Okay, well, a PCB is born, right? Okay, so it's not so much you could think of it as the parent process creates a child process if you think of the process scheduler as a PCB. We were talking about that a little bit last time, whether or not this guy is actually a PCB or not. Okay, but he really is treated as kind of a special case because, he kind of needs to be running at all times, right? So realistically, if we're going to treat him as a PCB, we're treating him as a very, very special PCB. So you might even ask, does he belong? Is it appropriate to have him be a PCB? But in any case, the process scheduler is going to create a child process, is going to create a process, a PCB. Okay, so this guy needs to have the ability to generate a PCB. So let's say public void create PCB. And let's see, we said PCBs require a process ID, who the parent is, and we decided that maybe we'd send in null for this initial one, and then a linked list of instructions. Okay, so in order to create a new PCB, we need to give him a process ID. So probably a unique process ID, right? Every PCB on the system should have a unique process ID. So let's go back to our process scheduler. So another thing that the process scheduler is going to have to keep track of is private int cur PID. So maybe inside of the constructor here, we say this dot cur PID is equal to 0. All right, so the very first PID we create will be PID 0. All right, and then we'll increment that. Make sense? So the process scheduler, when he's born, he needs to keep track of them. So when he's born, that's when this machine first booted up, right? Before any processes have been loaded and the CPU starts working on them. So when he's first initialized, he needs to know that the next process I create will have a process ID of 0. The process I create after that will have a process ID of 1. The process I create after that will have a process ID of 2, so on and so forth. So he's going to have to keep track of the processes that he's going to, the IDs of those processes. Make sense? All right, so when we're creating a PCB, somebody's going to call upon this function. It's probably going to pass in the name of the program being created in case they need to do something special. But in our little world right now, all PCBs are generic applications, right? We're not making a differentiation between Word and other, what's the name of the application that's running, when you're in Windows and you do you look at the task manager, it kind of gives you the name of the program that's running. So at some point, a process had to be associated with kind of a label. So keep track of those different things. We're not doing that in ours. We're just saying every PCB is created equal. They're generic PCB1, generic PCB2, so on and so forth. Okay? So when we create a PCB, we don't need any extra information because this guy's going to randomly decide what PCB was generated. Okay? So when we look at the constructor for a PCB, we need a PID, so we have that. We need the parent, so when one is being born, right now, we're always going to send in null for the parent. This guy does not have a parent. That means he's a top-level PCB. And then a linked list of instructions. So we should probably randomly generate some number of instructions for every one of our PCBs, right? All right, so let's just go ahead. We'll say our process scheduler. Let's go ahead and just give him an instance of the random class. I don't know why I said int there, but whatever. Private random R. And then import util random. Okay, so now we have an instance of the random class, and should we say that our PCBs have a random number of instructions between 10 and 50? Reasonable enough? Okay, so let's go ahead and we'll say r.nextInt, and let's go ahead and give this guy 41. So that'll get a generated number between 0 and 40, and then we'll add 10 to that, right? That's our number of instructions. That'll be 10 to 50 instructions. So we'll store that in the variable int num instructions. All right, oh, that's funky. All right, so num instructions. So now we need to go ahead and generate a linked list of those instructions, and we decided in our PCB we'd represent our instructions as a linked list of strings. So very simple instructions since our CPU, we don't have a CPU yet, so we imagine feeding Pac-Man an instruction, and right now those instructions look like strings, just for our simulation, right? All right, so we go into this guy here, and so we know how many instructions we need, so now we need to go ahead and create a linked list of strings called the instructions. This guy's going to be a new linked list of strings. Go ahead and create a loop to go through the correct number of times for our strings, for our instructions, and then we'll go ahead and say the instructions dot add, and let's add instruction concatenated with I. So it'll say instruction 0, instruction 1, instruction 2, instruction 3. Those are our instructions. Okay? So now I have the number of instructions. I filled up my linked list of instructions with actual instructions. I know what the next PID is going to be, and I also know who the parent of this guy is going to be, which is going to be null in this case, since we're creating a brand new PCB. All right, so let's go ahead and let's go back into Process Scheduler. So now let's go ahead and create our new PCB. So let's say PCB, the new PCB, is going to be equal to a new PCB, and the constructor takes in 3 pieces of information, a PID, so that's going to be our cur PID, the parent, null, and the instructions that we just created. So we'll pass it cur PID. So let me say this dot cur PID, pass it null for the parent, and pass it the instructions for our linked list of instructions. Then we want to increment the PID for the next PCB. This dot cur PID plus plus. That way we have the next guy will be PID1. After that will be PID2. All right, so now we just created a brand new PCB. And if we look at the constructor for PCB, what does he do? He sets the PID to whatever it was. He defaults the initial state to new. He sets the time slice to 0. Sets the parent to whatever the parent was. In this case, it's null. And then he sets a pointer for the instructions. All right. So now a brand new PCB was created. Where do I put it? Based on today's quiz. Job queue. So I'm going to say, let's say, add the new PCB to the job queue. This dot the job queue dot add the new PCB. All right, so that'll be our create PCB. Make sense? All right. What else did you have to do for your homework? That it? Okay. All right, so now we can create a collection of PCBs. So if we come out here to our driver, and we think about our driver as kind of being our operating system, so we might say initialize the OS. All right, but right now we don't really have this OS object yet. Okay, we might create it here in a second. In fact, let's go ahead and create it just so we have it. So I'm going to create a new class called OS. Let's see. Probably CUW OS, right? That's the type of OS, is the CUW OS. It's our brand new OS. Totally epic. All right, CUW OS. All right, CUW OS is going to have several things associated with it. Right now, all we have is a private process scheduler called the process scheduler. And then our constructor for CUW OS, we're going to go ahead and say this dot the process scheduler is equal to a new process scheduler, passing it no parameters, and that guy will go ahead and set the current PID to 0. So as the OS is booting up, the process scheduler is initially born, and before he can create any PCBs, he remembers that the starting PID is going to be 0. All right, and as part of the setup of our process scheduler, he already has created these queues up here. Just this. So right now we have a very simplified OS. The entire OS is about filling job queues up with PCBs. That's it. We don't even have a CPU. We got nothing. All right, we'll be adding some of those things. Okay, so we have our process scheduler. Okay, so now let's we're going to test this at the high level, I guess. So let's go ahead and what would this system? Just for right now, just let me make this public. Because we don't have a better way of. We haven't learned the next step yet for this part. All right, so we're going to make that guy public. So now inside of driver, we'll go ahead and create an instance of our OS, CUW OS. The OS is equal to a new CUW OS. And this guy takes no parameters, and he'll go ahead and generate our scheduler. All right, and now what we want to do is we want to have our scheduler go ahead and add a whole bunch of PCBs to the job queue. All right, so maybe this guy goes through where we're going to add 10 PCBs. So we'll go ahead and tell this guy to create a PCB. And let's go ahead and give a little commentary inside of our process scheduler for when a PCB is being born and that kind of stuff, just so we see it happening. So I'll go inside of our process scheduler, inside of create PCB. After we've determined the number of instructions, I'm going to do a system.out.println creating PCB with num instructions. Just say lines. And then we'll do a system.out.println added PCB to job queue. All right, so just a little commentary every single time we call this guy. We'll see that we're creating a PCB with 14, 38, whatever. We should see random amounts of instructions. And then at the end, we should see that he was added to the job queue. All right, so let's just make sure that all our pieces seem to be working together. So we'll create an instance of ROS, which creates an instance of our process scheduler. Then we're going to loop through, pretending like users double-click 10 times. Each time through, we'll ask the process scheduler to go ahead and create a PCB associated with each of those 10 programs we double-clicked on. And in part, inside of create PCB, we should get a little commentary printed out to the screen letting us know that some PCBs were born and all that jazz, right? All right, so go ahead and run this. So there is our created our PCB with 20 lines, added to the queue, 11 lines, added to the queue, 41 lines, added to the queue, so on and so forth. So far, so good? All right, so now we have PCBs created. They have some number of instructions, so each one has gone to the little vending machine at the petting zoo and gotten the little stuff that you feed to the goats. That's for you. I did that recently, the Milwaukee Zoo. I was, you wouldn't have wanted. I was there with my niece and nephew.
I'm not allowed to go through that.
There's a restraining order. You know, the big black goat from him, and the tiny, tiny white one, also from him. Or her, I'm not sure. This was weeks ago. Yeah, I had my family was in town. I think 3 or 4 weeks ago, something like that. I saw there was a giant tiger they have there, and it came by we were inside, it came by the window and turned around and it sprayed. It seemed like out of its butt, but I'm sure it's got like special things, right? So it sprayed up on like some kind of juices up on the window to mark its territory. That's awesome. Take video? And that coffee just tasted funnier than that. Do you know they actually there's a really expensive coffee made out of, it's elephant dung coffee. Yeah, it's awesome. Yeah, I think there's a coffee bean in wherever they're native in this place that the elephants eat the beans. And then they harvest the beans after the elephants have processed them. And then they sell those to people to drink in coffee. Huh? Yeah. So it's something with how their digestive system works that I don't know if it's acidic or acidic and basic or whatever it is, it does something to pre-roast the beans or something. Yeah, you can't buy it. Yeah, that's it. It's like crazy, like a little sample thing off Amazon, I think. It's like, and it gives you like 3 cups of coffee or something, right?
135 gram, 5 espresso sized cups.
Epic.
35 grams of other stuff less than that.
Yeah, but it wouldn't be coffee. I like coffee.
What would that do for your day? Could you be drinking coffee in the morning,
Well, I mean, it's not really any different than like, I mean, a lot of things. You know, we put pesticides. You know, when you get an apple or something like that, there's been bugs that have landed on that and done their business on them. I mean, they wash the beans. You know, it's not like it's right out of the pack and like, all right, send this to Amazon.
Bug did not.
We recommend you open your expensive coffee in the garage. True veterans don't even brew the coffee. They just eat it out of the bag. It's awesome. There's a tea brand as well, or a tea type. It's called Monkey Picked. It's a oolong green tea, where it's from some place up in the mountains in the Himalayas or something like that, where to this day, this whole lineage of these monkeys were trained by monks years and years and years ago. They climb up these mountain cliffs where the tea grows, and they pick the tea and bring it down to the people. Yeah, they sell it at Teavana, at Bayshore. Yeah, I mean, I think it's just normal. I think it's just normal tea plants. I mean, I don't think it's like anything. Maybe it's a special, whatever breed of tea, but it just happens to be that it's in a place that it's dangerous for humans to go, but the monkeys are going there already. So it's called Monkey Picked. Monkey Picked Oolong.
You can't just say it's like slaves, Dave.
All right, so you're like all uncomfortable because Doc is sitting next to you. Is that it? By the way, I saw this picture from the hackathon when him and Haxton, all them were sitting on my lap. You remember that one with the 4 people? You're sitting in the back. You've got the creepiest look in your face.
Not even saying that I advocate slavery.
Don't you see you have a black man sitting near you? We're just giving you and Doc a hard time. You know his name's Doc, right?
Yeah.
Do you know why? Oh. It's Doctor. DR. Stands for something. All right. So we've gone ahead and filled this guy up with some random PCBs. So now we have things in the job queue. What do we do with the things in the job queue? So these guys are PCBs. Last time we were talking about who are the living entities and who weren't. Who were, right? So PCBs aren't alive, right? They're like little buckets, little containers of stuff. But eventually they need to move out of the job queue and into the ready queue, right? Now, realistically speaking, is it possible for a job or for a PCB to need I/O before it's gotten any CPU time? What's the purpose of CPU time on a PCB? When you think about writing your programs, can you ask the user for input before your program starts running? So every single PCB has to get some amount of CPU time right off the bat, right? It can't go and wait for stuff until it's had some CPU time. Well, what does it mean to have what does it mean to get CPU time from a PCB's perspective? What line do I have to be in first of all? Okay, I have to be in the ready queue. Okay, as soon as I'm born, and I've now been created, and I've been added to the job queue, do I then immediately get in line for the CPU? Well, I wouldn't be born if I wasn't clicked on. Do we create a PCB representation of Microsoft Word before the user's double-clicked on it? Like, yeah, we're pretty sure he's going to want this. So we're just going to create 9, 10 instances of every single application on the machine. It'll run slow, but we want to be ready, right? User double clicks on Microsoft Word. A PCB is born. It's added to the job queue. Why? What's the purpose of that job queue? Yeah, we got to have one place, a go-to place to know about every single PCB on the system. All of them, right? All right. So, given that, that's what the job queue's for. Might we want to like query the job queue? Like, is this job, let's say we get some sort of interrupt that's talking about a job or something like that. We need to have some way to go look for that job. Otherwise, we have this collection of jobs, and we never actually go and look at it. Then the question is why did we have that collection of jobs? What are the reasons why we need that job queue? Kind of imagine how you use your computers, how you use the operating system. Why do we need to have one place where every single PCB on the system is, I guess, stored? Couldn't I extrapolate the job queue? Couldn't I generate the job queue on the fly? By taking whatever's in the ready queue and adding to it whatever's in the waiting queue? Doesn't that then, in what we've learned so far, doesn't that then equal the job queue? All jobs are either ready or waiting? Okay, why? Oh, so we have new. What else do we have? Running, terminated. So when you're running, what does that mean? What queue are you in if you're running? Yeah, you're not on a queue. It's game time, right? Hey, I think it's just like, in those bars that have the bull riding thing in the middle. Yeah, it's go time. Have you ever ridden one of those? I was at a bar one time that had that, and it had a weight limit.
I was about to say, if you had ridden one of those, you didn't have the video. Not sick.
Isn't that terrible? They wouldn't let me on it because I was too fat. I don't know.
You didn't buck very hard.
Yeah, maybe that's the thing. Like, the bull riders are either like ripped cowboys or humongously fat people. Two different ways of training for bull riding. You either build skill or overload the bull.
It might confuse you though at the event.
The guy's he's entering minute 17 of this bull ride. The bull's legs immediately snapped upon the gate opening.
So then the question arises, will they confuse you for the bull?
Yeah, the clowns come after me.
Get him in the car!
Hey. Isn't it weird that watching bull riding is fun, but you're like hoping they fall off and get stomped on? I know. I love when like the hoof smashes into the side of one of their faces, and then the clowns are running around like, oh, we got to get the bull away, but they know it's too late. It's awesome. See, that's something that probably shouldn't be televised, but they do it. And you can't help but watch. Like, can any of you flip through a channel and see bull riding on and not stop for at least 30 seconds? Really?
Yeah.
You wouldn't stop for 30 seconds just to see what happens in the current ride. I'm not saying you're going to get stuck for a half hour.
I would just assume there's a commercial.
Well, no, that's why you see bull. Oh, you just think it's a bull riding commercial.
No, I think it's just a different commercial on the actual bull riding.
Oh, I see. Well, yeah, then you get disappointed. That's right. We should make our own competition brand. We should start getting generic coffee beans, having all of you eat them. Bring in your collections. We're going to sell these as a new vendor on Amazon. We're going to do this for CU launch. It's a startup business.
We just call our OS coffee.
All right, what were we doing? We were talking about bull riding, right? Oh, 5 statuses. So we have new, waiting, running, terminated, ready. All right, so running, how many PCBs will have a status of running? Per core. Yeah, 1 per core, 1 per CPU core. All right, so in our simple little world here, we just have a single CPU. Right? A single CPU. And that's not really a queue though, right? A CPU, that's like the bull. So you leave the line, you're not in any of those lines. So we really can't extrapolate the entire ready queue, or I'm sorry, the entire job queue from just ready and waiting. And we need to know about everything. Okay, and even when a PCB state is terminated, isn't it still a job until it's actually been, I guess, removed from the system? Whoever's in charge of managing that job queue, process scheduler, he's probably going to have to monitor when PCBs enter a terminated state. And entering a terminated state means remove him from the job queue. He's no longer something I need to track. All right? So, a PCB was just born. His state starts off as new. Where does he go next? Ready queue. He immediately needs to step in line to talk to the CPU, right? CPU has to get the ball rolling with this guy. All right. Now we can think about all sorts of approaches we might take. Maybe new PCBs actually get high priority. That's not necessarily an unreasonable approach, right? Maybe they get high priority, and that way they can get the ball rolling, so to speak, on the launching the thing. Because chances are, if you double-clicked on an application, you kind of want that guy to start pretty quick. You want to feel like that's happening. All right, so we don't make him wait at the end of the line. But from our perspective, after we add him to the job queue, maybe we add him to the ready queue to get some processing. All right, so we'll go ahead and add him to the ready queue. But when we add him to the ready queue, we also need to update his status. So we have the new PCB dot. We need to have a way of accessing his status. Go into the PCB. He has the state. So let's create a public void set state ready. Okay, and this guy is going to say this dot state is equal to PCB underscore state dot ready. And we can probably extrapolate this and say we also want to have a set state running. Why? As he's making those transitions, we need to maintain the state of that CPU, or of that PCB. So set state waiting. Set state terminated. and set state new. We probably want to be consistent with how we are actually setting the states. So we probably want to go back and instead of, yep. Well, actually, hold on. You make a excellent point. Since a PCB sets its state to new when it's being born, you're right. We don't need this. We would never actually directly call it. Yeah, I don't think something becomes new again. All right, so we do need to have functions for changing them to other states. New is the default state.
In the process scheduler, when we add it, where do we want to add it to? Do we want to add it to the last spot, or where does add it?
You mean when it gets into the ready queue? Yeah. Ah, good point. Right now we're just adding them to the end for no good reason. Remember a few minutes ago I said, do we need to be able to do things with the job queue and that kind of stuff? Question is do our queues need to be a little bit more than just a linked list? Probably. Okay? Not just for the job queue, but when we add something to the ready queue, we might want to, add with priority, add with high, maybe we give it a numeric priority or something like that, right? So we might want to wrap our linked lists inside of a data structure called a scheduler queue or something like that. And that scheduler queue data structure then knows how to do stuff. Okay? It knows how to add something at the correct place, for example. All right, so realize we're out of time here, right? But let me just do this last piece here that you're packing up. We're all out of time, right? So down to 55. All right. So back in Process Scheduler, when we add it to the ready queue, it goes there. But what we probably want to do is immediately before that, let's go ahead and say this dot, the new, not this dot, just the new PCB dot set state ready. All right. And then let's go ahead and just give ourselves a little comment here for next time. We need to wrap our queues. Okay, we need to wrap our queues in a data structure. Make sense? All right, so I will see everybody on Wednesday. Sure. You want just process scheduler code? Yeah, I can. Yeah. Yeah, I'll do that here in a few minutes, and I'll put the link up on Slack.